Hello and welcome to our April Masterclass webinar with Syxsense. Today, we have our industry expert, Graham Brooks, here to give us an inside look into the vulnerability management and how to proactively eliminate all of those red lines using information and remediation. If you have any questions, please add them to the chat and Graham will reach out after to answer those. And with that, Graham Brooks.
Awesome. Thank you, Joe. Okay, so today we're actually going through a continuation of our previous masterclass. So if you were on for the March masterclass, what I'm going to go through for the next couple minutes is going to be purely review. And if you haven't seen the March masterclass, I strongly recommend that you start there and then watch this episode because there's a lot of useful background that we're going to go through, kind of walking you through how vulnerabilities are first identified, and then how threat actors start implementing their vulnerabilities, and then also how organizations can fix those vulnerabilities before the threat actors get to use them. In particular for that session, and then also for today, we're actually using the Log4j family of vulnerabilities as our framework for conversation. So if you haven't seen it, highly recommend you watch the March episode. But for right now, I'm going to start with a brief background, kind of give some framework for understanding Log4j. And then for the second part of today, we're actually going to go through how you would remediate Log4j on a server using the Syxsense family of tools. So first, Log4j, what is it? Why should we care? What are the vulnerabilities around it? So the Log4j vulnerability is what most people know it by, but the actual name for Log4j is actually the Log4Shell vulnerability. And the title of that vulnerability from MITRE and NIST is going to be CVE 2021 44228. It has a CVSS score of 10, which is the highest possible score. That's not good. That's a bad thing. The attack vector is the network. So as long as you have access to the network where that device with that vulnerability is, you can attack it however you want. The complexity is low. It's very easy to exploit compared to other vulnerabilities. There are no privilege required, which means that you can access their device using this exploit without having to put in any credentials. There's no interaction from an end user, so there's nothing, there's no way that you have to trick a user into performing an action for you to gain access. You can just do the work yourself for that access. And then the impact is huge. It's across the board, high impact against confidentiality, integrity, and availability. If you have any questions around any of what I just said around the CVSS score, privilege escalation, or confidentiality, any of those things, we have another webcast from last year where we go into significant detail about the CVE and CVSS scoring system so you can get a better idea of how the framework actually is applied. For today, though, I'm just going to move forward and we're going to talk a little bit about how Log4j was first impacted and kind of some of the intricacies around the vulnerability. And then we're going to walk you through how to fix it. So that's kind of the vulnerability. But what actually happened? What was the cause of this issue? So Java is a tool set. It's a language framework for applications. And there's a tool within Java called Log4j, and it's a product that's used significantly for logging functionality. It's logging for Java is its proper name. A lot of products that use Java are going to use Log4j as their logging tool set. And then even further deeper inside of Log4j, there's this tool called the JNDI API that allows you to communicate to different interfaces to pull and push data. One of those interfaces that you can use to pull and push data from JNDI into Log4j and then finally into your application is this LDAP connector. That's what's highlighted on your screen. That LDAP connector in an older version of Java, in an older version of Log4j, was susceptible to a privilege of escalation / arbitrary code execution attack, whereby someone just puts in a connection request from LDAP to a website that has a bad payload, and JNDI doesn't try to authenticate, it doesn't try to validate the code that it's running, it just arbitrarily executes whatever it's provided, which gives you access to the end device itself, whether that's a laptop, desktop, or most importantly, a server. This whole vulnerability kill chain was first discovered, I think, around end of November, early December of 2021. And it kind of blew up the whole IT industry because people were realizing that anyone who was running Apache, which is one of the most prevalent web hosting engines in the world, if you're running that, suddenly anyone can access the server backend as a full rights administrator, simply by sending a message to your Apache server, which is really scary. That's not a good situation to be in. And so the industry figured out that they needed to patch the Log4j interface. They needed to fix that dependency so that their Apache services and other Java-based applications that were critical to their businesses would be able to work without that particular vulnerability. So the industry came up with a solution. Patch Log4j, patch Java, you're good to go. The problem is if your Log4j component of your application is a direct dependency, meaning that the application you're running is the only thing that requires Log4j, all you have to do is patch that particular application and you're good to go. Unfortunately, a lot of organizations found that they had chained dependencies. So their software might require Log4j, and then other software further down that chain of custody also require Log4j. So there's multiple domains of remediation that had to take place. And so that's kind of the story arc in a nutshell. You have a vulnerability, it's really important to fix, and then you have a complex process of patching. Now, where it starts to get painful is the actual remediation. How do you take something complex like Log4j, test your environment against it, find the vulnerabilities, and then remediate those vulnerabilities safely and effectively? And that is what we're going to talk about today through the lens of the Syxsense console. We're going to show you how you can identify your problem children, the devices that are scary, unsafe, and then how you can remediate those devices against that critical vulnerability. So I'm going to stop sharing my slideshow, and I'm going to jump over to my Syxsense console, and we're going to take a look at the remediation path. All right, so now you should be seeing my Syxsense live interface. Before I get too far, I want to just give you a small architectural overview so you understand how our tool works. It's a cloud-hosted platform with an agent-based deployment scheme. So for each device that would have Apache or other Java products, you're going to have our agent installed on that endpoint so that we can manage it directly. And then once that agent's provisioned, the device will receive commands from the console to perform actions. We're going to spend our time today talking through some of those actions. In order to get there, though, I need to go over to my devices so we can look at my organizations. And then here you can see that I have these DigitalOcean virtual machines. These are the devices we're going to be looking at today because those are my cloud-hosted endpoints that are running, in this case, Apache. And I want to be able to fix those devices or validate that they're safe against Log4j. So to do that, I am first going to look at the vulnerability definition. We're going to see if the devices have been scanned for Log4j. And if not, we will then go through a process of remediation against those assets. So over here on my sidebar, I've got our vulnerabilities tab. And we're going to open up the security families. Syxsense is great for patching. We have lots of customers that use us to scan, find, and deploy patch content from vendors. That's going to be relevant for today's conversation. But a prerequisite to that conversation is we need to understand if we have devices that are vulnerable against the log4j issue before we can deploy patches that fix it. And so here under security, I'm just going to type in log4j, and it's going to pull up a short list of vulnerabilities. So here you can see I've got 6 distinct vulnerabilities that we can fix. This is our very first instance of log4j. This is a hash detection. So this is looking at any file that could be a Java-based application. And it's just checking to see if log4j exists in that application. You can see here that all of my devices, including those 6 hosts, are safe against log4j. So we don't have anything that needs to be fixed necessarily today. But if I had devices vulnerable, they would show up here. What's kind of comedic about this, by the way, people, is generally when I'm giving these demonstrations, I actually intentionally break some of my devices so that they're vulnerable to something before I show how to remediate. That said, log4j is such a scary one that I didn't feel comfortable doing that. So we're going to pretend for today that we have some vulnerable devices to work off of, while understanding that you don't actually want to ever leave your devices open to log4j. So if I had vulnerable devices again, they'd be right here. We also have a bunch of other vulnerabilities that we scan for around log4j, things that are specific to Apache, things that are specific to other aspects of the vulnerability, because there's actually multiple exploits at this point for the log4shell issue. So that's our identification scheme. Those 6 vulnerabilities is what we're looking for. There's a lot of products out there that offer what I'm showing you here, this ability to scan for a vulnerability. The problem for a lot of organizations wasn't actually finding their log4j vulnerable devices. That was the easy part. The harder problem was figuring out how to fix all those vulnerabilities in a way that was safe. So what we're going to do next is we're going to head over to Cortex, which is our automation engine. And I'm going to walk you through how we at Syxsense go through remediating log4j. So brief primer on Cortex. It's our automation engine. It's a drag and drop, no code workflow builder that you can use to create any form of automation, whether that's new endpoint development, creating a configuration management practice, or in this case, remediating a complex and high priority vulnerability against a production environment. So for now, we're going to go over to my server management workflows, and we're going to take a look at this Apache log4j remediation. It's pretty complex, I'll be frank with you, but we're going to break this down into 3 bite-sized chunks. The first chunk, which is right here, is our pre-flight checks. This is all the things we need to do before we remediate the vulnerability. After we go through those pre-flight checks, we are then going to go through our deployment process. This area right here is where we remediate the log4j vulnerabilities. And then the third chunk is going to be our post-flight checks. Everything right here. This is where we go through, validate that the device is healthy against log4j, and that also it's available, that we can use this resource again. Okay, so those are the 3 major components. Starting from the left-hand side, I'm going to zoom in here, and we're going to take a look at my pre-flights. The very first thing we're going to do is we're going to create a ticket. One of the most common problems that people ran into early on with log4j was controlling information, just being able to keep track of all the moving parts of the vulnerability remediation cycle. was a heavy burden because there are so many assets affected, so many different parts of the organization that had to be in community with each other, working on creating resolution. It was a massive undertaking. And so part of what we're doing here is making sure that we have baked in error correction and baked in process control so that we know what's happening on each device as it's happening. So step one is we're going to actually send out a ticket to your help desk or change control board stating that we have a device that has commenced its deployment against the log4j vulnerability. Once that ticket is in your change control, we're then going to follow that up with a shell command that we're sending off. Most likely this is going to go to ESXi or Hyper-V or AWS, or in my case, it's going over to DigitalOcean, and it's telling the service to snapshot my virtual machine because I'm hosting a virtual machine that's got Apache running on it. Then after we snapshot it, we're going to check in with our load balancer, and we're going to ask if this device is currently listed in our load balancer. You probably have more than one virtual machine serving the same content for a high availability framework. You have a load balancer in front of those devices, providing the endpoint access for anyone who wants access to your website. So we're going to check in with that load balancer and say, hey, is this device currently being used to provide content? If it is, let's pull it off of that load balancer so that it's no longer being used. And if there's an issue, it doesn't provide a denial of service. After we pull off the device from the load balancer here, we are then going to perform a service control. This is going to turn off Apache and make the device ready for a reboot. So that's most of our first stage. You'll note that we have a ticket update. This is going to send an update to our existing ticket stating that there's a pre-flight error. This pre-flight error is only going to happen if either we fail to create a snapshot of the VM. We absolutely do not want to change anything about this device if we weren't able to snapshot it. Don't want to do work that we haven't saved. And then we're also going to send out that same pre-flight error if we fail to revert our service from a running state to a stop state. Once we finish our service control successfully, we're then going to check and see if there's a currently pending reboot. Maybe there's pre-existing work that needs to run on this device. If there is that prerequisite reboot, we'll perform that reboot. And then we'll update the ticket stating that all of our pre-flights are done. The device is primed and ready for our remediation path. At which point, we're actually going to check in and say, okay, we have those 6 vulnerabilities that we understand could be relevant to this device. If they are, good to know, detected. If detected, deploy patches. If we have a patch for your specific software or more generally for Java, we will push out that patch to remediate the vulnerability on your devices. If there's a problem, if we didn't detect any vulnerabilities, we'll just let you know, hey, there was no vulnerability on this device. You've got this nice little snapshot now. Otherwise, we're healthy and safe. We're just going to skip our remediation path. Otherwise, we're going to send you an update stating that we did the work, everything's good to go. Or in this case, we're going to tell you, hey, there was a problem with deploying that patch. You need to know we weren't able to do the work. There's an error. And we just update that ticket as we go through. After we update, we're going to finish out the phase of our deployment by doing a post-provision reboot. Once that reboot has happened, we're going to perform another vulnerability scan. This time, we're just checking backwards and saying, okay, so we did the work, we deployed the patches. According to Syxsense, is this device now secure against log4j? If we find vulnerabilities, that's a problem that needs to be addressed. It means that whatever we patched may have fixed some of the items, but maybe there might be still another one of those 6 vulnerabilities that wasn't remediated by the patches that were available. If that is the case, we are then going to submit another ticket error stating, hey, we couldn't do the work because of X, Y, or Z. If we were successful, if there were no more patches discovered, no more vulnerabilities, everything is healthy, we're then going to evaluate the service. We're going to make sure that after we rebooted the endpoint, Apache came back online, because this isn't just an end user laptop or desktop. This is a production web hosting server that needs to be available for your customers. We'll check if it's running, which it should be. Awesome. We will then make another call to your load balancer and say, hey, this device can be added back into the load balancer queue. Once we've added it, we will close the existing ticket. And then finally, we will create one more snapshot. This is a post-provision snapshot. Now you have another save point stating, hey, we did the work. There's a snapshot before we did the work. The work was completed successfully. Here's a post-provision snapshot just in case. Otherwise, if there was an issue, for example, if we weren't able to start Apache or it was found to be in a pending kind of error state, we will submit a different message. Instead of closing out that ticket, we'll actually create another one of those errors that just gets added to that ticket log, stating that there was a post-flight error. In this case, because the service was stopped or was put in a start pending state. Then, instead of closing the ticket like we're doing up here, we're actually going to mark this ticket as critical. We're going to state, hey, this ticket, this is no longer just a change review thing. We now need you to know that there was a profound issue and we couldn't get the device all the way through the remediation path, meaning that we found vulnerabilities, the device is vulnerable and we can't fix it. At which point we're going to roll back that virtual machine to the state it was in at the beginning of this workflow, because we know that this device can't be remediated as it is today. Okay, so that's how you would remediate the log4j vulnerability on one device. We're talking about a production web host environment where you have 5 or 10 devices in a load balancer queue, all providing the same functionality, and you need to patch all of them. But you absolutely can't patch all of them at once because they're in a load balancer. If you bring them all down at the same time, suddenly you no longer have a service to provide to your customers. So you need to be able to automate this work, not just in parallel fashion. So doing the work on lots of devices, you need to also serialize it. So chunk 1 and then chunk 2. So some devices first and then other devices second, which brings us to our next layer of automation. We're going to also have a sequence of work, not just a set of work to be done, but a sequence of devices and actions. To build that, we're going over to the Syxsense Cortex sequence engine, and I'm going to create a log4j remediation path. We're going to start by selecting some devices, and I am going to target the endpoints in my cloud, but I'm not going to do all of them. I'm going to do 2 of them first, and then the other 2 second. I'm going to hit save here, save. And then I'm going to target a specific list of work. So that workflow we made before, I'm going to type in log4j, and then I have my remediation here. I'm going to drag that over to the middle. And then after I remediate those devices, I'm going to target another set of endpoints. So here we're going to target my next 2. So these guys right here, hit save again. And then we're going to do that same log4j, boom, just like so. And then finally, once we've done that remediation on the first 2 devices, taken them out of the load balancer, deployed the remediations, bring them back into the load balancer, deploy on the second 2 devices, go through that exact same process, we are then going to run a report. And this report is going to provide us with information telling us what work got done, how healthy the devices are, what needs to be performed still. And we're going to specifically push out the detected patches by patch report. I'm going to put in log4j remediation results. I'm going to put in tickets at syxsense.io. So this is my ticketing service that we're going out to. And we're going to say show zero count and show all of the things that we've deployed. Hit save here. And then we now have a full built out deployment mechanism that's going to push all those remediations to each device as needed. And then it's going to submit a report showing all of the work that's been done across all the endpoints. What's great about this is it's fully automated. So the only outstanding step would be choosing when you want to perform this work, which I would recommend doing after hours, maybe over the weekend, if you have that opportunity. I know a lot of people, when they were deploying out their log4j remediations, they didn't have that option and they just had to push it out in real time, take their website down for an hour or two while they were doing their remediations. Last thing I'm going to leave you guys with is what this detected patches report might look like, so you can get an idea of the payload that we're going to deliver at the end. One way that we can display this report would be by providing a security risk assessment. This will just show you how non-compliant or compliant your environment is. It'll show you how many devices have been patched against either all vulnerabilities or a specific family, like log4j. We can show you which environments are most affected, and then what operating systems are affected and what kinds of vulnerabilities we're finding. And then more specifically to the report that I included, we can show you the devices that got patched and then which patches we deployed. And the goal here would be you would see all of those DigitalOcean virtual machines, and each one would list maybe 2 or 3 Java or Apache specific deployed remediations. So you'd know, oh, okay, cool, we fixed all of these. And they'd probably show their CVSS score as being somewhere between 7 and 10. And you could say, okay, all of those devices have been remediated against the log4j vulnerability. We're safe, secure, and we can move forward with our lives. Awesome. So that is the full process of remediating log4j using Syxsense against a production web hosting environment. If you have any questions or comments about what I showed you today, I would love for you guys to reach out. If you have a contact already at Syxsense, feel free to hit them up. If not, jump on our website. We've got great resources there. We have multiple options there to contact either via chat, email, or phone. Thank you so much for your time.